Yeah, welcome to this session of our video tutorial. We are happy to have you here again. I hope you've taken out time to watch our other videos on variables, on quadratic formula, and the few videos we've posted. If you like them, please subscribe so that you see more of our videos. Today, we'll be looking at the nature of the roots of a quadratic equation. Remember, we said that a quadratic equation is that equation whose highest power is 2. Highest power is 2. Ax squared plus bx plus c equals to 0. This is a quadratic equation because the highest power is 2. And we say that it must have 2 solutions that satisfies the equation. 2 solutions that must satisfy this equation. Now, we want to know the nature of the solutions. These solutions are called the roots of the equation. The roots of the equation. Now, we want to know how to determine the nature of the roots. What can be your conclusion of the roots of a quadratic equation? Is it real and equal? Is it real and unequal? Or is it complex? Now, there are 3 natures we want to consider. And these 3 natures can be understood by what we call the discriminant. The discriminant. Although it's already there on the board, by what? The discriminant. Remember that this is our quadratic formula. We have shown this already, and we have shown how we got this. But under this radical, under this square root, we have this, b squared minus 4ac. This is what stands for the discriminant. Now, this is what you are going to use to determine the nature of the root of a quadratic equation. Now, look at what we have here. We say that if b squared minus 4ac is greater than 0, the quadratic has 2 real roots. 2 real roots. If the quadratic equation has 1 is equal to 0, it has 1 real root. If it's less than 0, the quadratic has no real root. Now, the whole of this can actually confuse you, but I'm going to explain what it means to you. Are you with me? We said let's start with the second one. We say if b squared minus 4ac is equals to 0, the quadratic has 1 real root. 1. Why do we conclude that it's 1? Let's look at what we have here. Let's see how we can understand this whole thing together. Let's see it. Now, let's say the quadratic equation we're looking at is x squared minus 6x plus 9 equals to 0. Are you with me? Now, let's have our discriminant to be equals to b squared minus 4ac. Now, in this equation, our a is what? Our a is 1. Our b is equals to minus 6. And our c is equals to 9. That's what we have. So let's substitute this whole thing inside the discriminant. So we have our d is equals to our b squared is minus 6 squared. That's what it means. Then minus 4 times our a is 1 times our c is 9. This is equals to, this and this is 36. Minus 4 times 9 is what? 36. 36 will give you 0. Now the condition here is that this quadratic equation has one real root. Now what does it mean for a root to be real? What does it mean for a root to be what? Real. To be real. If your solution is a number that can be found on the real line, you understand? This is the real line. Be it positive or negative, it is real. We say it is just one real root. So if you solve this quadratic equation, what will you get? If you solve it, what will you get? What you have is x squared minus 6x plus 9. You know that if you factorize this, your factors will be minus 3 and minus 3. Since this is the factor, your x1 will be 3 and your x2 will also be 3. These two are the same. So that condition applies to one real and equal root. That's what it should be. One real and equal root. It's real and it's equal. So if you solve a quadratic equation and then you have x1 to be a and x2 to be a, it means that the discriminant is equal to 0. This is part 1. We are going to watch part 2 to look at other conditions.